We're still doing the GRE Math. We only have 1 hour left, so I'm really going to focus. 36. Suppose S is a non-empty subset of R. Which of the following is necessarily true? A. For each S and T in S, there exists a continuous function f mapping 0, 1 into S. The f of 0 is S and f of 1 is T. Okay, let me think about that. What? For each S and T in S, there exists a continuous. That has to be true, right? You can always have one random point over here and another random point over here and just draw a line through them. Yeah, it should be A.
So this is not the one.
Don't worry, don't worry, started. Oh, mapping 0,
Hello,
1
folks, this is
into
Red Brown
S.
University physics grad student. Today we're looking at another physics GRE problem. In the last episode, we looked at electricity.
That's not
Today
necessarily
we're
true
magnetism.
because
So I
S
showed
might
you how
only
to
have a
derive the
finite
Biot-Savart
number
law,
of
which allows you to
values
calculate
inside
the
it,
magnetic field due to a
which
current
would mean
distribution if
necessarily
you're
that
some radius away from the
F
current.
is
So let me just recap
discontinuous.
that in 1 minute for those of you who missed it. So if you have a wire that's carrying some amount of current, and you want to calculate the magnetic
Each
field
U
due
that's
to the
not an
wire
S,
at
there's
some
just an
point
open
P,
subset of a
and this
U of
point
R.
P is, let's say,
That's necessarily true. That has
some
to be true.
distance R from the origin, and from any
36 is
given
B.
point
36
on
is
the
B.
wire, it's some distance R prime from the wire, then we can calculate the magnetic field
Okay, 37.
due to the current distribution at this point P using this equation, the Biot-Savart law, which is essentially the Coulomb equation, the Coulomb law, but for magnetism instead of electricity.
P be a linear
Mu naught I
transformation.
before
I'm going
pi,
to skip this.
dl cross
Maximum
r
number for
prime,
acute angles in a
r
convex
minus r
pentagon
prime squared
in the Euclidean
dq
plane
r
is
prime.
what?
So today we're
Okay.
going to be using this formula, this
Acute
equation,
angles in
for
a
the magnetic field
pentagon
to calculate
in
the
the
magnetic
Euclidean
field due
plane.
to a certain current distribution.
Well, here's the thing.
Okay.
If it's convex, we
Before
know
we
there
do that,
can't be a
maybe
single
let me
angle
clear
over
up what this equation
180
is saying.
degrees.
So mu naught is
So a
just,
pentagon.
okay, let me go through it step by step. This is the
a
magnetic
triangle
field
has 180
at this
degrees.
point.
Square
So
has
really this should be
360.
B of R.
Looks like it's
B
S minus 2 times
at,
180 around here.
At this point P.
So
okay,
pentagon has 8
this is the
times
magnetic field
180.
at some distance R from the origin.
So
Mu naught is a constant. I is the
acute
current
means
carried
they're
by the
less
wire.
than 90.
DL is a small
So
section of the wire. So this is
let's
DL.
say we push everything up to the
R
maximum.
hat prime
So
is
we
this
have
is the unit vector in this
3
direction.
angles
This is R hat
that
prime.
are exactly
R
180
minus R
degrees.
prime is essentially the distance to the wire from the origin.
But
and
then the 5 other
over
angles
all parts of the wire. So
that
basically, we're
aren't
chopping up
would
the
make up
wire
for it.
into
Okay.
many discrete parts, and we're calculating the magnetic
What
field
about
due to this
4
part,
times
due to this
90
part,
and
due
4
to this
times
part.
180? No,
And then
that
we're
doesn't make
adding
up
up
for it either.
all the tiny magnetic fields to get the
So
total
let's see.
magnetic field at some point R away from the origin. So that's the basic idea of the Biot-Savart.
Maximum number.
So now what we're going to do is apply this
let's
to a
think of
concrete
it
problem and see how it works.
this
So here's
way,
the
right?
Here's the physics theory problem. So we have the following current distribution. We have, okay, and so we have current going down this wire, and then it goes down, and then it follows this semicircular loop, and then it keeps going down this way. So this is my current flow, and our goal is to calculate the magnetic field at the center of this current distribution. Okay, so we're going to break this up into 3 pieces. We're breaking this problem up into this piece,
Okay,
this
so
piece,
a Kengon is 8 times.
Okay, so let's go ahead
I thought it
take a
had
look
8
at the
sides.
magnetic
I'm
field
dumb. I'm
created
dumb.
at this point P.
Okay.
Okay,
So 5
due to
times
each one of
90
the
and
3
5 times
current
180.
pieces. So I'm going to call this 1, 2,
That's not
and
going to make
3.
the threshold.
Okay, so let's start with the magnetic field generated by this
Wait,
line.
is that greater than or equal
So you
to
should
8
know that the
times
magnetic
180?
field due to a current
Well, then 5
wire
times 90 is
at some
450,
distance r from the
greater than or
wire
equal to 540.
is
Yeah, no,
just
that's
mu
not
naught
true.
I over
4 times 90 and
okay. Where does
6
this come
times
from?
180
It comes straight from Ampere's law. Remember that Ampere's law tells us that the
is
curl of the magnetic
360
field
greater than or
is
equal
mu
to,
naught I
well, it can't be
plus 1
equal
over
to.
c squared partial e partial
Yeah, it's
t.
3. It's 3.
Oh, this is wrong. This is wrong. Mu naught j. Mu naught j.
Because
Where
4
j
is a
the current
boundary value.
density.
You can't
So
have
if I
a
apply Ampere's
180
law to
degree
this
angle
current
and
carrying
still
wire,
call it
and let's say this is a
convex.
steady state situation, so there is no
Is that
change in
code?
the electric field, then I have the curl of B is mu naught j. The curl of B is mu naught j.
Okay.
Now I'm going
If
to
the input
integrate both
integer
sides
is
with
88,
respect
set
to
I
the area.
equals 1,
Okay.
while I is less
The
than
area.
88.
Okay. Now by using Green's
Replace
theorem,
I
this area integral
by
becomes a
I
line
plus
integral.
1.
So this becomes B dot
So
dl.
set
So this
K
becomes a line integral around
is equal to n.
this Amperian loop.
While
This is what we
K
call
is
an Amperian loop. It's just like a Gaussian surface, but instead of taking
greater
the
than or
area of a
equal
Gaussian
to
surface, here
I,
we're taking the perimeter because this is a line integral
begin,
of the Amperian loop.
if
And this
I
is
is equal to
what is
K,
the current density
print
times the area?
I,
If not the current itself,
replace
mu naught I.
K
But
by
what is
K minus
the
1.
perimeter of this circle?
Okay,
If it's
so
if it
let's
has
do
a radius
one
of
full
r,
run
that's
through
just 2
of the
pi r.
logic. We
So
set
B
I
times 2
equals
pi
1,
r is mu
then
naught
I gets
times I.
incremented
So
to
that means the
2,
magnetic field generated by
then
this
K
current
is
wire
equal to
is mu
88,
naught I over 2
K
pi.
gets decremented to 87.
Okay, so that's where this equation comes from. Okay, it doesn't come from thin air; it comes from Ampere's law.
Okay, while K is greater
So now
than
that
or
we
equal
know,
to I.
now that we know the magnetic field due to a current
So you
carrying
get
wire at some
3,
distance away from the
then
wire, can we calculate the magnetic field due to this wire at this point P? Indeed we can, but we don't have to use this equation. Why? Because this is some distance r from the loop. But notice that this point P, where we want to calculate the magnetic field, is right along the loop,
and
right
this is
along
going
the
to keep
wire.
going
So
on
we cannot
until at
apply
some
this
point
because if we apply
it's
it,
going
then
to be
r
like
is 0.
44
The distance from the current carrying loop
and
is 0. That
45.
tells us you have an infinite magnetic field at this point P. But that's obviously not true because the wire ends right here. So somehow we have to calculate the magnetic field without using this equation. So how do we do it? We go back to the basics, which is the biosynthetic. But don't worry, this will come into use when we do this one. So, okay. So let's write down the biosynthetic law. So the magnetic field at some distance is mu naught I over 4 pi times the integral of the cross product. Okay, so if we look at the biosynthetic law and try to apply it here, then what do we have? Let me grab a different color. So first of all, what is our dl vector? Our
I have
dl
a
vector
hunch it's
is
going to be the
in this
integer
negative direction. So it's a tiny step in the minus z
88,
direction. So this is our
right?
dl vector. Wow, that is horrible. And what is our r hat prime vector?
Yeah, I have
Our
a hunch
hat
it's going to
prime
be B.
vector is in this
Wait,
direction.
that's
This
for,
is our r hat prime vector. It's
wait,
from our point P to this this
oh, it's because I
small
skipped
section
37.
of the wire. So
So
dl
this
hat,
has to be
or sorry,
shifted
dl, the
up
dl vector
by
is in the
1.
minus z hat direction.
Let S be the set of all functions f from R to R. Consider the two binary operations plus and dot.
Really?
Okay.
Is it muted?
Dot is definitely not commutative.
Probably.
So E is out of the question. Okay, that's difficult. Plus and dot. Satisfy that f of z of x
Mic check, 1 2 3.
I mean, what if we set like g of x is equal to h of x is equal to e to the x? Then we have like f of 2e to the x is equal to 2f of e to the x. But that's not always going to be correct, because like then set f of x is equal to the square root. So yeah, that's not true. Okay, g of f of x. Okay, yeah, that looks like it's going to be true. It's probably C. Let L be the line that is the intersection of, oh boy, an equation of the plane that contains 0, 0, 0, and is perpendicular to L is... Okay, let's see. X plus y plus z is 3. X minus y plus z is 5. X plus z is 4. And that means that y is equal to -1. Okay, great. So that means that the vector that is parallel to this line is going to be y component is 0. X plus z is 4. Z is 4 minus x. So like, for example, in the xy plane, 4 minus x looks like this. So it's just going to be -1, 1, right? Yeah, I think it's going to be like 1, -1 in that fashion. Then we want a plane that contains 0, 0, 0, and that is perpendicular to L. I forgot how to do that. Okay. Yeah, I guess we'll go through trial by error. X is equal to z, so that gives the vector, yeah, it's composed of the vector. Let's look at it in the xyz plane. Oh, okay. X minus z is 0, just gives x is equal to z, or this, which means that it's composed of this vector and this unit vector. Or in other words, 0, 1, 0, and 1, 0, 1. Is that perpendicular? No, neither of those are perpendicular. Well, that one is perpendicular. Okay, so 1, 0, 1 is what we are looking to implant. X plus z is equal to 0, just the opposite way around. So this time you have -1, 0, 1, and then the same wrong vector. X plus y minus z is equal to 0 gives us what? X plus z is equal, x plus y minus z is equal to 0 gives us what? I mean, 1, 0, 1 works. and I think 0, 1, 0. Yeah, that might just do it. Oh, wait. Oh, wait. Wait. Yeah, I think it's x minus z is equal to 0. Should be A. Okay, let z be the set of positive integers. G plus, okay. Let d be the metric. Okay. If n is in the set of positive integers, then n is an open subset. Well, I mean, 1, 2, and 3 can't all be true. Neither can 1 or 2. 1 and 2. So, oh, something can be closed and open at the same time, no? Yeah, okay. Every real valued function defined on z is continuous. No, that can't be true because of the way distance is defined. Because, like, yeah, no, that can't be true. So 3 is definitely wrong. 2, I'm gonna wager, is every subset of z is closed, which means that its boundary values are included in the set, I think. I think it's 1 and 2. Wouldn't make any sense otherwise. Yeah, I think I'm gonna wager it's 1 and 2. Wait, is n an open subset? No, it has all its boundary points filled in. 1 is not. 1 is not correct. I'm gonna say it's A. 43. A curve is given parametrically by. Oh boy. Okay. So we have the parametric curve t squared plus 2t, 3t to the 4th plus 4t cubed. So let's see. The vector that represents dy dx is just, well, no, the magnitude of dy dx is what? Okay, at the point 8 comma 80. So what is t at that time? T squared plus 2t is equal to 8. Yeah, so t is 2. So at the point t is equal to 2 is dy dx in this case is just, well, okay, so dy dx, I believe, is 12t cubed plus 12t squared divided by 2t plus 2. Okay. because that's dy dt over dx dt. So that implies that this is equal to what? 12t squared times t plus 1 over 2 times t plus 1. So we have 6t squared. Okay. Then we have the d squared y dx squared equal to d squared y dt squared times or divided by, oh, okay. What's the second derivative of this? That's just 2, right? Oh, that's x. Okay, and the second derivative of this is going to be 36t squared plus 24t. So it's going to be 18t squared plus 12t, and at t equals 2, that calculates to 24 plus 72, which is 96. 44. Why is the real value function defined on the real line and satisfying the initial value problem above? Then the limit is x approaching negative infinity of y of x is what? Okay. Oh, it's a differential equation. Y prime plus yx is equal to x. So I think, oh, this is a product rule problem. So, yeah, this is just d dx x times y. Wait, no, it's not. And I'm pretty sure, in this case, f of x is half x squared. Oh, okay. So we have, this is d dx of y e to the half x squared. Whoa, go, 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 go. So then integrate both sides. Go, 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 go. Go 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 go. The integral of that is, oh no, I don't want to integrate that. Oh, but taking the derivative just challenges me. Or do we do the u sub? Wait, if half x squared is equal to u, then du is equal to x dx, right? Yeah, can't we just do that? We have the integral of e to the u du. Yeah, that's rad. So that's just equal to e to the u. Yeah. So that's just equal to e to the 1 half x squared. Okay. So that means y is equal to negative, y is equal to negative 1. Okay. So it's a constant function. What? Oh, no, that's not bad. Because all you have to do is think about the square 0, 0 to 1, 1. Now in this square, this is what x looks like. And this is what cosine of 96x looks like or something. I know. Now, I'm assuming they're using radians here. If they're using degrees, well, then I'm screwed. But let's assume they're using radians. So then, in that case, you've got to remember that this means it will have a frequency of 2 pi divided by 97. So that means that one full cycle, which will make them intersect twice, is going to be done in 2 pi over 97. So then we just have to find 97 over 2 pi rounded down. So 97 over 2 pi is around 16. So I'm going to wager it's 15. Because 97 over 2 pi is like 96 over 6 or so. The ladder 9 meters in length is leaning against the vertical wall. Oh, it's a related rates problem. Okay, so the bottom end of the ladder is moved away. Okay, so let's... So we know that we have the length and the height. So the length squared plus the height squared is always equal to 81, right? So taking the derivative here, 2 length of time, length prime, plus 2 h of time, h prime, is equal to 0. And now let's cancel this out. And here's what we do. We know that h prime of t is always equal to 2 because it's increasing. Wait, no, that's length prime of t. Because the bottom end is being pulled away at 2 meters per second. This is constantly increasing by 2. So then, how fast in meters per second will the top end of the ladder be sliding downwards at the moment the top end is 3 meters above the ground? Now that's what we call a tricky question right there. Okay. So find h prime of t when h of t is 3. Oh, okay, that's pretty easy. Because then, at that moment, h of t is 3, and this total length is 9, L of t is just 81 minus 9, the square root of 81 minus 9, which is the square root of 72, or 12, no, not 12, 6 root 2. So that means we have 12 root 2 plus h of t, which is equal to 3, h prime of whatever time it is equal to 0, which means that the answer just h prime is equal to negative 12 rad 2 over 3. So it's C, 4 rad 2. Phew, okay. Next problem, please. The function f from r to r is defined as follows. That's kind of some Dirichlet stuff. It is continuous at x equals 0. I don't think it's differentiable. Yeah, see. Okay, which of the following is the best approximation of the, oh no, directional derivative at the point 0, 0, pi in the direction of the vector? Oh, I'm forgetting everything right now, bruh. I think you have to take the gradient, which is equal to the partial derivative at x, the partial derivative at y, and the partial derivative at z of z. So let's see, the partial derivative in the x direction, 6xy plus z plus nothing. Partial derivative in the y direction is 3x squared. Partial derivative in the z direction is 1. What the do? What the do? What the do? Oh, there's an easy way to approximate it. All you have to do is take 0, 0, pi, right? What's the value at 0, 0, pi? G of 0, 0, pi is pi, obviously. But then you move it in the direction of the specified vector. So something like 0.1, 0.2, pi plus 0.3. So then, now what do we have? We have 0.1 squared times 3 times 0.2 plus pi plus 0.3. Now let's just subtract that from pi and divide that by the distance between the 2 points, which is...
Okay, you want to redo the yesterday's one? Later. Later is not going to happen. You can do it in 5 minutes.
4 and 4.
Just do it in 5 minutes and upload it and then move on. You already did it twice, so you should be able to do it quickly.
Okay. So now we just need to ballpark estimate this. So what do we have? This is pretty small, first of all, but I'm gonna multiply both the top and the bottom by 10. Oh yeah, that's really small. I'm gonna wager that's like 0.2, even smaller than that. What's the largest order of an element in the... Oh, I know that. It's no. Let's see. What is it? Group of permutations of 5 objects. Oh, it's 5. That's the cyclic.
Is that what number is on?
50.
Wow.
Let R be a ring. Oh no. Let U and V be two-sided. Okay. Ideals. Is U plus V composed of ideals as well? By the distributive property, I think so. U intersect V, yeah, that's definitely true. And U dot V. No, that's debatable. I'm gonna go 1 and 3, which is D. Which of the following is orthonormal in the column space of the real matrix 1 minus 1, 2 minus 3 minus 1, 1 minus 3, 2, 2 minus 2, 5 minus 5. What? So by orthonormal, well, I can tell you something. These two are definitely not orthonormal, so we can cut them out of the picture. For the column space, oh, the column space is 1 minus 1, 2, minus 1, 1 minus 2, 2 minus 3, 5, minus 3, 2, minus 5. So let's reorganize this a little bit. If I add this to this one, we get the vector -1, -1, 0. So that's certainly one of them. Orthonormal also means the magnitude of each vector should be 1. So let's keep that in our head. 1 minus 1, 2. Oh, wait a second. If I multiply this by 2 and add it here, we get -2, 2, that's 0, 2, -3, that's -1, -4, 5, that's -1. No, that's +1. Okay, those two are definitely not orthonormal, in fact. Those two are not orthonormal. I'm going to see if 0, 0, 1 is a vector. If so, we should be home free. In fact, I'm going to wager it's E. It's E. It's E. Because the first vector we found, basically the same format as the second vector. And that's what, okay, combinatorics. 10 professors, 20 different courses. Each professor needs 2 of the courses. Each course will have 1 professor. Okay. Well, all that's going on here is each professor, it's just 20 times 18 times 16 times 14 times ... times 2, which I'm pretty sure is A, but I'm not completely sure. Is it 10 factorial times? Well, what is this? 10 times 9 times 8 times 7 times 5 times 4 times 3 times 2 times 1 times 2 to the 10. Excuse me. I'm gonna assume there was a typo made and just say B. Okay, let f and g be continuous functions of a real variable such that f of y times y minus x dy, okay? G is 3 times differentiable. So g prime of x is what? It's f of x times x minus x minus f of 0 times 0 minus x. And then g double prime of x is x f prime of x plus f prime f of x. And g triple prime of x is, okay, so it's going to be 2, which is b. The real number is chosen at random in the interval 0, 3, and the real number y is chosen at random from 0 to 4. What's the probability that x is less than y? Okay, well, here's what's going on. The probability that x is equal to y or y is equal to x is practically 0. So we have 4 cases. Either x is less than y. Okay. Either x is less than y or y is less than x. So let's see. 0, 3, real number y's. Okay. So here's what's happening. We have a real number chosen at random from 0 to 3, which means the average value is going to be 1.5. So we just want to roll the odds that are not, we want to roll the odds 2.5 out of 4, because that entire area from 1.5 to 4 is going to work. So it's 5/8. Let's see. Oh, holy crap, what is that? What's the value of, is it partial fractions? Oh yeah, it is. Okay. Hey, 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 hey. Is it Arccan? Oh, man. I'm just gonna make a guess and say it's C. Which of the following are true? We have 20 minutes to solve the next 10 questions. There is just a constant C such that log x is less than ln x is constantly increasing. It diverges. But the square root of x also obviously diverges. And I think you can do that. Yeah, I'm pretty sure you can say that. Just to be sure, though. Yeah, that should be possible. 1 should be true. I mean, let's say ln x is greater than c rad x at some point. Then what would x have to be? e to the square root of x. Okay, so e to the c rad x has x over here. No, that's not. Oh, we have ln of x to the 1 over c is greater than the square root of x. So ln, now we do know that ln of x is less than x most of the time. Yeah, which means that logically, if this is even smaller, this grows even slower. So yeah, okay. So I'm gonna say 1 is true. What about 2? No, that is definitely not true. That is most definitely not true. No, that grows way faster. Why? Because that right there is equal to n times n plus 1 times 2n plus 1 over 6. And the cubic function will always outgrow a square function. 2 is false. Sine of x minus x is less than or equal to c x cubed. Well, negative x, well, x is already less than or equal to x cubed most of the time, but for all real x, taking the absolute value of x cubed would make it look like this. Meanwhile, sine of x minus x just looks like this. But if you're taking the absolute value, I suppose it looks like this. So I'm going to say no, because there's definitely some points at which it's greater. Like at 0, for example. Wait, no, but sine of zeros. Okay. Okay, that's fine. I'm gonna go that it's B. Let x n be a, ooh, that's not good. A real number of the open interval 0 to 1 over n. Which of the following is true? Yeah, that's true. F is continuous real value function final 0 to 1. Is a Cauchy convergent sequence. Yeah. Yeah. Well, technically, 0, 1 open doesn't include like limits going to infinity. So I'm going to say it's A solely because of that. Following parametric equation. Is that a polar integral that you're currently throwing at me? A spherical integral, actually. Or cylindrical coordinates. I don't even remember anymore. What is it? Do do. What do do do. I'm not going to do that question. 59. Let A be a real 3x3 matrix. Which of the following doesn't imply that A is invertible? That implies it. That implies it. I don't know about that one. That might imply it. I'll have to look at it. That implies it. And that implies it. Pretty sure C. That's the epsilon delta thing. Okay. This property is equivalent to which of the following statements? Wait, f of x. Oh, that's a greater than or equal to sign? That means it could be unbounded. But it's not equivalent to that. Ba da da dee dee doo. Da dee doo doo da dee doo doo da dee da doo doo. What do 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 die die do 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 die 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 do die do die do die do die do die die do die do die do die do die do die do die die do die 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 do 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 die 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 die. Joy, 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 joy. Joy, 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 joy. I'm gonna say it's C. Okay. Oh no, not these ones. Okay, let's see. Tank initially contains 3 grams of salt dissolved in 100 liters of water. Okay. So here, what we're doing is finding salt in the water as a function of time, such that S of 0 is equal to, well, 3 grams over 100, and S of t is such that well, what's the differential equation that describes this? I'm feeling dumb right now. So we have the S of t, S prime of t is equal to what? That's fine. I'll just go. Yeah, I think I'll go C. Honestly, this is just guesswork at this point. Let S be the subset of R squared consisting of all points xy in the unit square. What? Oh, compact, totally disconnected. Pretty sure it's totally disconnected. Or is it? Well, between any two irrationals, you can find a hole. I'm going to say it's totally disconnected right now. Let's S be the subset of R2. Wait, no. Gosh. Okay, for any non-empty sets A and B of real numbers, okay, it's just a product. Okay, if supremum of A is greater than the supremum of B, the greatest element of A dot B here is clearly just the greatest element of A. Oh, it could be negative numbers. I'm gonna go see. Do do die 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 die. Or is it E? Because possibly the infima might be the only negative value.
Did you change the name? Also, leave the mic. Okay, baby. See you soon.
64. What's the value of the flux? What? Of the vector field F? Not going to attempt this right now. Oh, that's a sphere. Yeah, that's the upper half of a sphere. With radius 1. Oh, that's just a radial. Oh, I might be able to do that. Isn't that just the integral EDA, or am I dumb? Yeah, and the magnitude of each one is just going to be 1. Yeah, so isn't it just going to be the surface area of the sphere, which is going to be 4 pi r squared over 2, which is 2 pi? Yeah, it's just going to be E. And 65, let G be differentiable, let F be the function of a complex variable Z, defined by, holy crap. F is analytic. Oh, I didn't study complex analysis. How am I supposed to know this? Well, we know that, okay, G of 3, 2 minus G of 1, 2. We know F of 3 plus 2i minus F of 1 plus 2i is equal to E cubed sine 2 minus E sine 1 G1, 2. Just going to throw a guess out there and say it's going to be D, because that looks similar to what I'm seeing right now. Okay, ring of integers mod 17. Units O. Which of the following are generators? 5, 8, or 16? Anything that's not a factor of 17, no? Like, for example, you have 5, 25 mod 17 is 8. Then 125 mod 17 is what? I don't know. 6. And then I mean 3125 or 625 by 17 is what? 0. No, that's not 0. That's a factor of 15. 3. Yeah, and it looks like that's going to provide the entire chain. 2 looks like it would do the job as well. 3, I'm having a little bit of debate about. 16 squared is 256. So, I mean, 17 minus 1 squared is congruent to what mod 17? 17 squared minus 2 times 17 plus 1 is congruent to 1. Yeah, so 16 is not a generator. It's just going to be 1 and 2, right? What? If 8 is not a generator, 64, that gives 12. Oh, or 8 only gives even numbers. Okay, so I'm going to wager it's 5 then, which is B. Alright, so now just to fill in the guesses, so these are ones that will probably be incorrect. So, first one, I'm just going to guess B. Second one, I'm going to guess A. Third one, I'm going to guess E. Fourth one, I'm going to guess D. Fifth one, I can skip a fifth one. Okay. So with 4 minutes left, we should be done. So let's see if we can check our answers. Okay, here we go. All right. So we have, what is P plus? Oh, okay. So 1 is E, 2 is C, 3 is D, 4 is A, 5 is E, 6 is C, 7 is C, 8 is B, 9 is A, 10 is A,
Wow.
11 is, where's 11?
Wow.
B,
Wow.
12 is B, 13 is D,
Wow.
14 is B,
Wow.
15 is A, 16 is B,
Wow.
17 is B, 18 is A, 19 is E, 20 is E, 21 is B, 22 is C, 23 is D, 24 is A.
I thought it's
Wait, no.
34 really.
Huh? What?
34, 35?
Huh?
Oh, 25. Okay. Okay.
25 is A, 26 is D, 27 is D, 28 is D, 29 is E, No, 29 is
It's
C.
raining now.
30 is A.
How many you got wrong?
I don't know yet.
Quite a few. 31 is C. 32 is E. 33 is C. 34 is B. 35 is B. 36 is C. 37 is C. Okay, so none of our guesses were correct. 38 is C. 39 is B. No, 39 is D. Sorry. 40 is C. 41 is A. 42 is E. 43 is A. 44 is B. 45 is C. Okay, 4 in a row is not good. 46 is C. 47 is B. 48 is A. No, 48 is B. 49 is B. 50 is D. 51 is E. 52 is A. 54 is C and 55 is D. 56 is D. Wow, okay, so I did not do good on the latter half of the test. 57 is C. 58 is B. 59 is E. 60 is D. Holy crap. Okay, 61 is E. 62 is C. 63 is E. And this is E. And we got these 3 correct.
Excellent, baby.
No,
Excellent.
it was not that excellent. So let's see how many we got wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So I got just over half correct.
That's good.
Oh, wow.
That's good.
Wow, you still
Okay,
congratulations,
so
huh?
Oh, wait. So let's see.
Yeah.
What would that be? Only a 600 out of 910.
Out of 910.
Yeah,
910 is the
max.
perfect score.
Yeah,
So you got 600, right?
yeah.
Next time
Wow,
you're
that's
better.
fast.
Yeah, it's good enough for a first attempt.
Yes. You remember AMC? You improve like that.
Yeah.
Okay.
There aren't that many.
All right. All right. Say something for the viewers.
Yeah, so
Look at me. Yeah.
this was good enough for a first try, and also there was a lot of things that I had to do, such as like explaining my entire process to the viewers, reading out every question, scrolling, writing out all of my answers, doing all of the work, and like moving the smartboard. So a lot of those accumulated to add time, and so I had to rush the latter half of the test, which led to me getting a whopping, well, let's see. The latter half starts from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, which led to me getting only 12 out of 33 of the second half questions correct. So I'm sure that if I had paid equal concentration to both the first and second half, well, what would I have gotten? The first half, I got only how many? 11 questions incorrect. So if I had paid the same amount of attention, I would have got somewhere around 720.
Wow.
So still, I think this is good enough for a first try, and we'll try again next time.
Very good.